Right, hi everybody. Hope you're all well. Okay, let's have a look at 8C, modeling linear growth and decay. So growth and decay are when quantities increase, that's your growth, decreases, that's your decay, by the same amount. So the linear bit means by the same amount. So a couple of examples there. So here's a graph. Both these graphs start at 20. This one goes up by 2, so growth. This one goes down by 2, so decay. You can see the graph going up, the graph going down. Growth and decay. Here's your growth, there's your decay. Here's a bit which may be a bit confusing to you. So this is saying that the next term is the previous term plus the growth. So D is our growth. So plus the growth. And they've just used the letter D here. It could be anything. And this one here is saying that the next term is the previous term minus D. So that one is the decay. So it's just going down. So here, plus D is plus 2. Here, minus D is minus 2. So that's all that's that. D there is, in this case, is plus 2. In this case, it's minus 2. And D is always a constant. So for linear, D will be a constant. In this case, it's adding 2. In this case, it's subtracting 2. So a few little things. If you give money if you deposit money in your bank, so somebody gives you some money for your birthday, you decide you're saving up, so you put it in the bank is effectively borrowing money from you. And they will give you interest for that. If it's simple interest, they will give you a certain amount of money each month or each year or each quarter. If you borrow money from a bank, a loan, simple interest loan, you have to pay money back to the bank. So it's a fixed amount. So it's the same each time, regular time periods. That could be every week, every month, every quarter, every year. So simple interest, linear growth. Simple interest, linear growth. The amount borrowed or the amount that you invest, if you're borrowing money or you're giving money to the bank, is called the principal. And it's usually a percentage of this principal. So it might be 10%, 15%, 5%. So don't freak out with this. So this formula here is just the same as that previous formula, the one where we had the graph and it was just plus 2 each time, okay? So here, we've got a certain amount, so the principal, the amount of money you start with. So it's similar to when we were doing the previous chapters, A and B, where you always had your starting point in your sequence. So this is like the starting point. And what we're saying is the next term is the previous one plus the amount. Now that amount might be a percentage, okay? So if we see R is the percentage, we know we have to do R divided by 100. So if our amount of money was $1,000, and it was 10%, we're working out 10% of $1,000. That's how much we add on each time. We will look at an example. Here is one. Cheryl invests $5,000, so that's the principal. That's V0. Investment account pays 4.8%, so that's our R is 4.8%. Model this simple investment using the recurrence relation of the form that looks like this. So basically we're saying Vn is the value of the investment after n years. It's not telling us how many years. It doesn't say that it's 5 years or 10 years, so we just leave it at n years. V0 is the principal, so that's easy. V0 is 5,000. Write down the interest rate, R, and use it to determine the value of D. So D is going to be R, 4.8, divided by 100, times V0, which was our principal. So it's $240. $240 each per annum. So each year we're adding on $240. So it's in the right form. V0, yep, we've got V0. Vn plus 1 equals Vn plus 240. So we've answered the question. Quite a few steps. You'll be fine. Okay, so here is the investment. So there's our V0, Vn plus 1, adding 240 each time. Use the model to determine the value of Cheryl's investment after 3 years. when will it first reach $6,000? So I think this is something nice and easy we can do on our calculator. So writing down our relation. So basically we're just copying out the question there. So we type into 5,000 into our calculator, press enter, then do plus 240 and press it 3 times. So 1 time, 2 times, 3 times. So it's 5,720 bucks. When will Joel's investment first exceed $6,000? So that's why we pressed it a few more times than the 3 here, because we can see here that it's just gone over 6,000 there. So after 5 years, so let's just check. 1, 2, 3, 4. It's very close there, isn't it? But it's not over. So it's 5 years. The investment is that. Depreciation. So this is just going the other way. So going down. So a new TV bought for $2,000 is unlikely to be worth anywhere near this amount in 5 years. Probably see them all out on the side of the road sometime, don't you? People just finish with their TV, they just stick it out on the road. Very little second-hand value in TVs these days. So businesses, schools as well, need to estimate the likely value of an asset after a certain amount of time. So if you think about those overhead projectors or those big TV screens that we have in each of the classroom, they might have cost quite a lot of money at the time, but if we've had them in the school for 5, 6, maybe even 10 years, they're going to be worth very little. If you were trying to resell them at the end, they're going to be worth very little. So we're going to use that to model a linear decay recurrence relation. So just the same as things going up, but things are going down. So this formula here, very, very similar to that previous formula. So here we've just got take away D. Yeah, so to working out the value of D, it's still R divided by 100 times the principal. But this time we're just taking it away. So new car purchased for $24,000, 2014, 6 years ago now. Car depreciates at 20% of its value each year. Model it using this recurrence relation. So you'd already have this written down, wouldn't you? So you'd know that this is just to work out that you've got to use the one with the minus in because it's depreciation. So Vn is the value of the car after n years of depreciation. So V0, price of the new car. Now we're going to work out the value of D. So it's 20%. So it's 20 divided by 100 times 2,400, 4,800 bucks a year. So each year it loses $4,800. So here we are. We've written our formula out. V0 initial value 2,400. Vn plus 1 equals Vn minus D. We worked out D to be 4,800. So here's that same situation. Use it to find the value of the car after 2 years. When will its value depreciate to 0? So although the car will probably not actually be worth 0, effectively to this company, they're saying that it's not worth any money. So I write down the recurrence relation. So again, we're just copying out what's in the question. Again, get our calculator out, 2,400, enter, take away 4,800, press it twice, 1, 2, 14,400. And this one here comes to exactly 0. So it's after 1, 2, 3, 4, 5 years. So after 5 years, that car is effectively worth 0. So if you knew the company people that own that car, you could offer them $1,000 and you'd get yourself a 5-year-old car for $1,000, which for an 17, 18-year-old is a pretty good value, isn't it? Pretty good value. Often that won't happen when it's just luck that happens to be exactly 0. Unit cost depreciation. So this is where it's not a percentage, it goes down by the same amount each time. So if you think about it, a photocopier might be used how many copies it makes. So if you're working in a busy office and it's doing thousands and thousands of copies every day, then it's going to be worth less than if you work in a small office and it's hardly used at all. So same formula, we're just taking away D. Previously with the car one, we had to work out the percentage, then we know it was going down here. It's going to be the cost per unit. So if you think about it, it's not going to cost a lot for one piece of paper, is it? We're using that formula that we've used previously. So it's just the same one there. Professional gardener purchased a lawnmower for $270. The mower depreciates in value by $3.50 each time it's used. If you imagine the Jim's mowing guy, each time he goes out and does that, he's losing $3.50 because this lawnmower is going to wear out and all that sort of stuff. So he's going to need to do quite a few lawns in a day, isn't he? So this one's a bit easier than the previous one, so we don't have to work out the percentage. So there you go, write out V0. V0 is the value of the mower when it was new. Previously, it was the value of the car when it was new. Yeah, $270. Write in the depreciation, $3.50. Write down your answer. V0, $270. Vn plus 1 equals Vn minus $3.50. Question on it now. Find the value of the model after it has been used 3 times. How many times can the mower be used before its value depreciates less than $250? But it's at 270 already, so I wouldn't have thought it's very many. Here's our relation. Type it into our calculator. Take away $3.50 each time. So what does this have to use 3 times? 1, 2, 3 times. So $259.50. And there's our 249. So 1, 2, 3, 4, 5, 6 times. That's probably even in the first day if he's busy, isn't it? So here's a little table. So linear, simple interest. Linear, flat rate. Linear, unit cost depreciation. So this is where we have to use the percentage formula to work out what the value of D is, how much it goes up each time. So it's growth, it goes up. Decay or depreciation, so it goes down. We have to work out the percentage. The unit cost one, we don't have to work out the percentage, we just use the value of D. That's like our lawnmower was $3.50 each time it was used, yeah? They got 3 videos to watch now. So you need to pause the video that I'm doing now, go onto Google Classroom, find the PowerPoint, go down to the page, this page here, and there's 3 videos, one on simple interest, one on losing money, and one on unit cost depreciation. Okay, so watch those 3 videos. Then there's just a couple of questions to do. Okay, this is getting quite tricky stuff now, so make sure you spend a lot of time watching the videos, making sure you understand it, and really get doing those questions really carefully and properly. Mr. Patch, over and out.